Have you ever spent hours in the field fighting brush, losing line of sight, or reshooting your points because the data just didn't look right? It's frustrating, it's a waste of time, and it's a waste of energy. And sometimes the embarrassment of explaining why a job took way longer than the client thought it should have. A lot of this comes down to the limitations of traditional survey tools. GPS and total stations can't always see through trees, smoke, and rough terrain. And when you're stuck working around those limits, you lose efficiency and you lose confidence in your results. That's where LiDAR comes in. It's a proven technology that started decades ago. And today, it can change the way you handle big, messy, time-eating jobs. Hey guys, I'm David from Benchmark, and today we're talking about the power of LiDAR for Surveyor. So where did LiDAR even come from? LiDAR stands for Light Detection and Ranging. Think of it as a cousin of radar and sonar. So sonar sends out sound waves and listens for echoes of faraway objects. Radar does the same thing, but it uses radio waves instead. And LiDAR is the same thing, but now it's using light waves instead of sound or radio. In the late 1930s, a scientist named Edward Singe started asking, if sound and radio can measure distance, why not light? His team started shining very powerful searchlights up into the sky, measuring how long it took for the light to bounce back off of objects like clouds. And so for the next 20 to 30 years, that's exactly how they used it. Scientists would shine searchlights into the sky to measure the height of cloud cover. And it wasn't until the first laser was invented in the 60s that actually the same team that invented that laser then developed the world's first LiDAR, which used a point source laser to measure a very exact distance to a point far away. And now that they're using lasers instead of searchlights, they could send out very, very precise light pulses. Now they could study fog, haze, smog, and other atmospheric distribution problems in ways that radar couldn't. And soon after that, NASA started using LiDAR to study the surface of the Moon, Mars, and even Mercury. If you've ever seen those very detailed maps of the Moon's surface, LiDAR had a hand in that. So in the 1970s and 1980s, LiDAR started coming back down to Earth. And once GPS became more available for aircraft navigation, the two technologies could be combined. And planes could take both these data sets, merge them together, and fly overhead, just capturing tons and tons of topographic data. And still to this day, they have those very large, garbage can looking LiDAR units that sit in aircraft and they fly a few thousand feet in the air to capture topo data. By the late 1990s, commercial LiDAR scanners began to hit the market, and they could shoot up to 25,000 laser pulses per second and could see multiple returns on those pulses. So now, rather than having to shine a single laser at the moon or at the Earth and measure the distance and plot it and move on to the next one, they could be plotting upwards of 50,000 points per second on their surface. That meant for surveyors that they could finally cut through dense canopy and foliage and actually get the true ground topographic data that they were looking for. So we know all this about LiDAR now, but how does that affect you today? LiDAR isn't just for NASA or government contracts anymore. Tools like the DJI L2 can fire up to 250,000 pulses per second, and they can see up to 5 returns, which means they can fly your job and be storing more than 1 million points per second. And if I lost you in the numbers, the reason it can do that is because the DJI L2 will see 5 returns on that laser data, which means 250,000 pulses in a second correlates to about 1.25 million points received per second, which means you can fly your big messy jobs with something like this at a much lower elevation, much closer to the ground than the big fixed-wing aircraft with the big trash can LiDARs, which means your data on the ground is much, much more accurate. You'll be able to see the top of the canopy, the branches, the understory, and the bare earth, which is what you care about. And this for you means walking less on 600-acre topos, cutting hours or even days off of your field time, and delivering results that your clients can trust without second guessing them. So next time you're staring at acres of thick brush on a job site, and it looks like it's gonna eat your whole week just cutting grass and hiking through hills, just remember that LiDAR can do the heavy lifting for you. So coming soon, we're actually gonna be making more videos on how LiDAR works, how it can save you time, and help you avoid having to revisit any job sites in the near future. So stay tuned for that and check out this video on the Matrice 350.